This is section 7.2, circumference and area of circles. And like normal, when we start here, make sure that you are getting your vocabulary in. So make sure that you take all of those words. You can go ahead and stop the video, take those words, get them in your vocabulary right now. That's one of the first things I need you to do. All right, so let's talk about, what are we talking about? A circle, it says, is a set of points in a plane that are the same distance from a given point, which we call the center. What exactly are they talking about? Well, let's say that we have a point, and if we measure a certain distance out, there's a point there. Let's say we go that same distance out here, and so on every way around. If we do that all the way around, that's what we get. We get a circle. So in a circle, and of course my drawing is a little off here, but from this point to the edge, everywhere we go is the same distance. That's what they're saying in that definition. If we go from that center circle, from that middle point to the edge, that is known as the radius. If we go all the way across, that is known as the diameter. And if we go all the way around, we call that the circumference. So those are kind of our terms that we want to use here. Now, there is a special relationship between the circumference of a circle and the diameter of a circle. And there's this little activity up above. It asks you to measure the cylinder and then roll it out and figure out what it was. And, well, if you do that, what you find is no matter what the diameter is, the circumference is always approximately 3.14 times greater. It's actually, it's much more than that, 3.1415926, and that continues on forever. There's no end to this particular number. That, of course, we call pi. That's the Greek letter pi. So what we know is there's a special relationship between the diameter and the circumference, and if you divide the circumference of the circle by the diameter, you will always get pi. And that's just the way circles work. Okay? So usually we'll use probably 3.14. Sometimes, if they want a fraction, they'll use 22/7 for the approximate pi. But for most of us, most of the time, we'll just use a calculator and we'll use 3.14. If your calculator has a pi key on it, you can use that also. However, that will carry it out far beyond 3.14, and so sometimes your answers might be off slightly with what we get. So here's a formula, and this is a good one that you need to get into your notes. Once again, a formula for the circumference of the circle, and what we were just talking about related to pi. Pi times diameter is the circumference, or another common one, maybe you didn't know the diameter but you knew the radius. Well, 2 times the radius gives you the diameter, of course, and so 2 pi r is another formula. So get these two formulas in your notes. You need to know both of those. All right, so let's do a problem. Find the circumference of a circle. If we know, all we have to tell you is the diameter. If we say the diameter is 9 inches, you can say, oh, well, that's easy. I know that. Circumference is pi times diameter, pi times 9. Or if we put it into the calculator, 3.14 times 9 gives us approximately 28. I'd probably round that off to 28.3 for my answer. I wouldn't bother to write all that out. Now, if you do, I'm not going to count it wrong. You're just wasting your time. On the second problem, they didn't give us the diameter. Notice that they just gave us the radius here. Well, okay, then we use that formula, 2 pi r. We have to double the radius to get the diameter anyway. So 2 times pi times 7.2. If we put that in on the calculator, we would get 45.2. So circumference. Remember, two formulas: circumference, pi times diameter, or 2 pi r. Either one of those, depending on what we have available to use, is the one that we should use. All right, let's talk about area now. Now, this is kind of weird, so I'm going to try to explain this to you. What they're saying is, let's say that we cut this circle up into all these pie-shaped pieces here. So we've got all these pie-shaped pieces, and I take those and I put them over here. And notice that I line one of them up this way and then the other one that way and so on. So what they're saying is, if we went all the way around this circle, that would be my circumference C. But notice that I only have half of those on this side. So what we're saying is that this distance across here is 1/2 C. Therefore, and that distance is 1/2 C. So that's the same thing. And if we do this, notice that this looks like a parallelogram. And remember, a parallelogram, when we wanted to find the area of a parallelogram, was base times height. So if we know the base and we know the height, we can figure that out. Well, my base is 1/2 of the circumference. The height would be, think about it, the height is from here to the edge, that is the radius. So really what we're talking about, if I go down here and I substitute in, and I say instead of base, I'm going to use 1/2 C. So my area is 1/2 times the circumference. I said the height was R. Well, what do we know the circumference? We know the circumference is 2 pi r. So I can take this and substitute it in, and I can now get 1/2 times 2 times pi times r. That was what I substituted in. And I've got this r here. So I substituted this area, this part in for C. I get 1/2 times that, 2 pi r times r. And, 2 times 1/2, well, that cancels out. So I'm left with pi. R times r is r squared. So the formula of a area of a circle is pi r squared. So anytime that we want to figure out the area of a circle, we need to know the radius. Now, if we know the diameter, we can always figure out the radius. But we need to know the radius in order to calculate that problem. And then you just take the radius squared times pi. So once again, another formula you need to get into your notes. That's an important formula. All right, so let's do an example. Actually, if we have a radius of 8 kilometers, we're just going to plug that into my formula, pi r squared. My radius was 8, so it's pi times 8 squared. 8 squared equals 64. And we would plug in 3.14 for pi, 64. And if we did it on a calculator, 201.1. And these were kilometers, so these would be square kilometers. On this second problem, they give me the diameter. But, I can't use diameter. I need to use the radius. So I'm going to have to take the diameter and divide it by 2 to get the radius. So that's going to be pi times 7.5 squared, or pi times 56.25, and that would be approximately 176.7. And now you're going to definitely want to have calculators when you do these. That's just a lot more work if you don't. Okay, let's go ahead and do A, B, and C down here. All right, what they want you to do is find the circumference and the area of each of these. So let's take a look at the first one. It says circumference. Circumference is pi times diameter, or 2 pi r. And in this case, the first one, we have r, we have the radius. So I would put in 2 times 3.14 times 11. And I would get 69.1 centimeters. To find the area, area is pi r squared. 3.14 times 11 squared. 11 squared, 121. Punch that in, we would get 380.1 square centimeters. For B, if we want to find the circumference, in this case we know the diameter, so it's pi times diameter. 3.14 times 5 miles, and that would be 15.7 miles. If we want to find the area and we know the circumference, or rather we know the diameter, we need to divide the diameter in half. So we're going to take 5 divided by 2 and get 2.5 for the radius. Okay, so pi r squared, 3.14, r squared, 2.5 squared. Punch that in, I would get 19.6 square miles. And to do the third one, we have the radius again. So for the first one, for circumference, 2 pi r, so 2 times 2 3/4 inches times, I'm sorry, that is the radius. Let's put in pi first. 3.14 times 2 3/4, and that would come out to be 17.3 inches. And for area, we would get pi r squared, of course. Pi is 3.14, r 2 3/4 squared, total 23.8 square inches. Okay, before we begin, I would like you to do just a couple more. Take a look on page 322. Let's forward to those pages, 322. And I want you to work these problems. Find the circumference and area of each of these. Let's do 3 and 5. 3 and 5. And I want you to do those, and I'm just going to give you the answers. Put them in your notes, and then I'll check those when you bring your notes to me. So make sure those are in your notes.